Welcome all. I am Mr. Ajit D. Malivasekar, working as an assistant professor at Department of ENTC Engineering at Walchand Institute of Technology, Solapur. So today we are dealing with beam area. So this will be the part 1 of this video because before deriving expression for beam area, we should know what is plane angle and solid angle. So after this video, student will at the end of the session, student will be able to understand concepts of plane angle and solid angle. So first we are dealing with plane angle. So what is plane angle? Consider this is a circle having radius r and we are taking one arc and this arc is having length L. So this arc will subtend angle at the center of the circle, this angle. So this arc having length L is subtending angle at the center of the circle. This angle we call it as theta, that is plane angle. Okay. So now how to calculate this angle theta, that is the plane angle. So we are having formula. So theta is equal to arc length L divided by radius of the circle, that is L by r. So after this you will get value of theta, that is plane angle, and its unit is radian. Okay. So now what is plane angle then? So plane angle means it is the angle subtended by arc of length L at the center of the circle of radius r. Okay. So now when 1 radian angle becomes, so we are having criteria, that is if arc length L is equal to radius of the circle, what will happen? The angle which is subtended at the center of the circle, this theta will be 1 radian. For example, if arc length is 1 meter and r, that is the radius, is 1 meter of the circle, so theta, that is the angle, plane angle, becomes 1 radian. Okay. So now what will be the angle of the entire circle then? We are having entire circle. So we are calculating angle only for this arc having length L. So what will be the angle of the entire circle then? So as we know, for entire circle we are having length, that is the arc length, is nothing but circumference of the circle. So we can calculate, as we are having arc length, that is the 2 pi r, that is the circumference of the circle. So we are, by putting the values in the formula, theta is equal to arc length by r, that is 2 pi r, that is the circumference of the circle, divided by r. So r get cancelled, so we are getting 2 pi. Okay, that means plane angle of the entire circle will be 2 pi radian. So that means our theta, that is the plane angle, will have limits between 0 and 2 pi. It will vary between 0 and 2 pi. So this is all about plane angle. And for entire value of the circle, that is for 2 pi, the angle, that is plane angle, take the shape of a circle. That is for entire circle, if we calculate the angle theta for entire circle, so this plane angle will take the shape of circle, that is the full value, that will be 2 pi. So this is all about plane angle theta, and it is always measured in radian. This plane angle is also called as two-dimensional angle. Okay, because we are always measuring this angle only in a particular plane. Okay. So now next is, okay, again one point is missing. So that is, as we know how to calculate theta, that is the arc length divided by radius. So if we know angle theta and if we know radius r, then we can also calculate arc length L. So L is equal to r theta. From above equation we can calculate. So L, this arc length, will be r into this theta, and this theta will be in radian, not in degrees. Okay. So this L equal to r theta, this is required in second part of our video, that is the expression for beam area. Okay. So now solid angle. Okay. So concept of solid angle, already we have studied about plane angle since our 4th standard. That is from primary school we are learning what is plane angle, we are dealing, we are calculating. Okay, but now solid angle, again there is one concept. So it is actually three-dimensional angle. Earlier the plane angle we were dealing with only 2D structures or in two dimensionals only. So now solid angle we are always dealing with in three-dimensional structures. Okay, so now what is solid angle then? So consider this is a sphere and we will mark a circular surface area on a surface of the sphere. So this is S. So this is a circular area which is on surface of the sphere. So this circular area will subtend angle at the center of the sphere. This subtended angle will be three-dimensional angle and this is in circular form. So this angle which is subtended by a circular surface area on the sphere is nothing but three-dimensional angle or solid angle. Okay, so that means when solid angle is formed, whenever we are having circular area on the surface of the sphere, this circular area will subtend solid angle at the center of the sphere in a circular form. Okay, example is in birthday parties we are using hats, that is birthday caps. So these are cone like structures. Okay, so these birthday caps or birthday hats are nothing but the examples of solid angles, means how actually solid angle looks. Okay, these birthday caps are the examples of solid angle. So now how to calculate the solid angle? Now solid angle is subtended because of surface area. Okay, so that means to calculate solid angle we are having formula, that is omega, that is the solid angle, that is equal to circular surface area S, this is the S, divided by r square, that is the square of radius of the sphere. So by putting the values of surface area and r, we are going to get solid angle. Okay, and unit of solid angle is steradian. Okay, so now we know solid angle, right? So solid angle means it is the angle subtended by circular area on the surface of the sphere at the center of the sphere in a circular form. So this angle in a circular form will be solid angle, and example is birthday cap. It will exactly look like a solid angle. Okay, now we know solid angle. So when one steradian angle is made, that is one steradian solid angle is made. So criteria for it is very simple. If circular surface area that we are marking on the sphere, if circular surface area is equal to r square, then solid angle becomes one steradian. For example, if we are having sphere having radius 1 meter and the circular surface area that we are marking, its value is 1 meter square, then the circular solid angle which is made at the center of the circle, this circular form, this solid angle will be 1 steradian. Okay, now what will be the value of solid angle of entire sphere then? Just like in two dimensional we studied value of plane angle of entire circular. So here we are dealing with three dimensional structures, so value of solid angle of entire sphere. So what will be the criteria? So for entire sphere, what is the surface area? We are having 4 pi r square as a surface area of the sphere. So by putting the values, that is the formula of solid angle is circular surface area divided by r square. So now we are having circular surface area as 4 pi r square, that is the entire surface area of the sphere, divided by r square. So r square and r square get cancelled, so we have value we get as a 4 pi. That means value of a solid angle of entire sphere will be 4 pi. So now for full value of the solid angle, it will take the shape of sphere. Just like our plane angle, for full value of a circle, it is 2 pi. So for 2 pi, it take the shape of circle. So similarly, the solid angle will take the shape of sphere when we are measuring entire value of the sphere, that is the entire solid angle of the sphere. Okay, so this is all about plane angle and solid angle. And without knowing this, that is what is plane angle, what is solid angle, how to calculate these things, we can't understand how to derive expression for beam area. Okay, so in next video we will start with how to derive expression for beam area. So these are the references. So thank you.